Today I'm going to talk about trig substitution. Trig substitution is a little bit different than direct or U substitution in that instead of using a single variable to represent your substitution, you're going to use sort of a reverse approach and sort of input a new function of a different variable. So when you're doing these types of problems, there's a few sort of forms you need to recognize. So when we're looking at trig substitutions, if you find something in this form where you have a constant squared minus the variable squared, where your constant is greater than 0, or a is greater than 0, then you're going to use a sign substitution. So basically you have, wherever you see x, you're going to substitute it for a times sine of theta. Okay, so you just have to take the square root of your a squared, which is just a. Okay, then the next one we have is of the form a squared plus x squared under the square root, or you have 1 over x squared plus a squared, where a is greater than 0. Notice in the second form that there is no square root. Okay, so this one has a square root, this one doesn't. Okay, and then when we use this one, you're going to have x equals a times tan theta. Okay, that's when you use this form. Okay, and then the last one is if you have x squared minus a squared, where a is greater than 0. You're going to use a secant substitution. So wherever you see x, you can input a times secant of theta. Okay, so this one looks fairly similar to, let's see if I can put it in, to the sign substitution, if you can see it there. Here we have the constant minus the variable. Here we have the variable minus the constant. So hopefully you can remember that. In this one we just add them, so it doesn't matter what order they're in. Okay, so I thought we'd just start with an example. So here's our example. We're going to evaluate this indefinite integral, and it's 1 over 5 minus x squared, the quantity, to 3/2. So first you have to recognize that this is a fraction, so a power that's a fraction means that you're actually having some sort of root, and in our case it's a square root. So we get to use our trig substitution. So if we actually look at the first trig substitution, we have our constant minus our variable, perfect, and it has to be under a square root, which it is. So we're going to use our sign substitution. Okay, so we're going to take x, we're going to make it equal to the square root of our constant times sine of theta. Okay, fairly simple. And then we're going to take the derivative on both sides. The first side we're going to take in respect to x, so that's just dx. And on the second side, if we take it in respect to theta, then we have square root of 5 cos theta. Okay, so now all we have to do is plug them into our formula up here. So then I have, oops, I forgot d theta, because we're taking the derivative in respect to theta. Alright, so dx is equal to the square root of 5 cos theta d theta, right, so that got rid of the dx, over 5 minus the square root of 5 sine theta squared to the power of 3/2. So notice I didn't lose anything in terms of quantities. They're all there, I just made my substitutions. Okay, so then all you have to do now, as you've done your substitutions, you just have to clean up. So, square root of 5 cos theta d theta. So if I square these terms, I'm going to get 5 sine squared theta to the power of 3/2, right? So 5 minus 5 sine squared theta to the 3/2. So I'm going to put equal signs, just so you know where we are. Okay, the next thing I'm going to do is, because you can't really simplify at the top very much, so I'm going to try and simplify the bottom a little bit. So I see that there's 5 in both terms. I'm going to factor that out. So that gives me 5, 1 minus sine squared theta to the power of 3/2. One thing to note is that, oopsie, forgot a bracket. Okay. One thing to note is that if we remember what this identity is, remember you have sine squared theta plus cos squared theta equals 1. Right. Remember that identity? Probably one of the more easier ones to remember. So if I take sine over to the other side, then I'm just left with, sorry, if I take sine squared over to the other side, then I'm left with cosine squared. Okay, so we'll just do that, clean up. And I'm also, at the same time, I'm going to take this 5 out of the bracket, so I'm just going to apply the 3/2 to it. So 5 cos theta d theta over 5 to the 3/2 cos squared to the power of 3/2. Okay? Almost there. So now what I'm going to do is I'm going to convert this to its fractional form, the power I mean to its fractional form. So you have 5 to the 1/2 cos theta d theta divided by 5 to the 3/2. And then, if you remember here, so you have a, whoopsie, I forgot my theta. If you have a squared and a half power, those are just going to cancel each other. So we're going to get cos cubed theta, right? And then it's out of the brackets. Okay. Then we realize here, oh look, we have the same terms. So whenever you have the power on top, we're going to subtract the top power from the bottom power, right? As for the power rules. So if I do that, then I'm going to have 5 to the negative 2 over 2, right? Because 1/2 minus 3/2 is negative 2 over 2. And then I have here a hiding 1. So 1 minus 3 is 2. So then I have cos to the negative 2 theta d theta. Okay. I don't like how this looks. So I'm going to actually change it a bit so that it looks more pleasing to me. So if I say 2 over 2, that's the same as 1 over 1, or I could just say it's 1 over 5. So 1 over 5, right? I'm not doing anything too tricky here. Times cos squared theta, and I'll put d theta on top. Okay. So now what I'm going to do is I'm going to take the 5 out of the radicand, sorry, the integrand. And if you remember, cos, anything over cos is just secant, right? Because that's just that identity. So that will leave me with secant squared theta d theta. Because I don't really want to integrate this. I'd rather integrate this because I know what the actual integral is. And if we remember correctly, if I remember correctly, the integral of that is just tan theta plus c. Okay? And then the last thing we have to do is just look at our substitution, which was x equals square root of 5 sine theta. Okay. If we divide both sides by square root of 5, that'll leave us with x over the square root of 5 equals sine theta. So if we looked at our triangle, a right triangle, and we make this the angle we're looking from, so that would mean that this being opposite is x, right? Opposite x over hypotenuse, which make this the square root of 5, okay? And then that would make this last side 5 minus x squared. Okay? So if we're looking for tan, which is opposite over adjacent, we would have tan of theta equaling x over the square root of 5 minus x squared. Okay, so we're almost done. So we just have to input the information. So we have 1 over 5 tan of theta plus c, right? So our final thing we have to write down is just 1/5 of tan, which is x over the square root of 5 minus x squared plus c. All done.